Hello, in this short lecture I will give a proof of the Pythagorean theorem. Pythagorean theorem in a right triangle actually says that the square of the hypotenuse is equal to the sum of the squares of the perpendiculars. Or if we look at this triangle, it says actually that the hypotenuse squared, and the square of the hypotenuse is equals to the perpendiculars and the sum of the squares of the perpendiculars, or a squared plus b squared equals to c squared. So let's assume that the right angle triangle ABC is the right side of the drawing. We have to prove that a squared plus b squared equals to c squared. In order to prove this thing, we actually made a copy of this right angled triangle, and the copy of this triangle is actually here. And actually we built the copy of this triangle by the fact that we drew side B along the length of side A. So in the same line of side A, we drew side B, and then actually we raised a perpendicular whose length is the length of side A. So this is actually A and this is B. And here we have 90 degrees because it is A is perpendicular to B. So now we have two triangles, ABC in the right side and triangle ABC in the left side. And actually the two triangles have two sides that equal to each other. Side A in the right triangle equals to side A in the left triangle, and side B in the right triangle is equal to side B in the left triangle. Okay? And also the angle between side A and side B is equal in those two triangles. The angle between side A and side B in the right triangle is 90 degrees, because it is a right triangle, so it must have as a triangle that is 90 degrees, and the angle between side A and side B is also 90 degrees, because we built it like that side A is perpendicular to side B. So we have two triangles that equal to each other by two sides, A equal to A and B equal to B, and also the angle between side A and side B in the left triangle is equal to the angle between side A and side B in the right triangle. Therefore, the triangle ABC on the right side coincides with the triangle ABC on the left side, according to the rule side angle side. That is to say, two triangles that have two sides that are equal to each other, and also the angle between these sides is equal to each other in both triangles, so the triangles are congruent. Side A in the right triangle equals to side A in the left triangle, side B in the right triangle is equal to side B in the right triangle, and the angle between side A and side B is 90 degrees in both of the triangles, and therefore they are coincides. And since the third side of the triangle ABC on the right side is C, then because of the overlap of two triangles, then the third side of the left triangle ABC is also C. Okay, so this is C and also this is C. Okay, let's mark the angle between sides A and C with alpha. The angle between side A and side C will be alpha, as you see in the red color. The angle between side A and side C in the left triangle is also alpha, as you see in the red color. And as we know, the sum of the angles in a triangle is equal to 100 degrees. In every triangle, the sum of the three triangles is always 180 degrees. therefore, if we label this angle as x, the angle between side B and side B is x, then x plus 90 plus alpha equals to 100 degrees, because the sum of the angles in any triangle is 180 degrees. Okay, so as you can see here, in the left triangle, x plus 90 plus alpha equals to 180 degrees. And therefore, x will be equal to, if we subtract 90 degrees from both of the sides of the equation, x plus alpha equal to 90, and then if we subtract alpha from both sides of the equation, x equals to 90 minus alpha. Okay, as you can see here, is x equals to 90 minus alpha. And suppose that this is an unknown angle, the angle between side C and side C in the middle triangle will be labeled as y, because we don't know what is the angle, and this is, as I've already told you, is alpha, and x equals to 90 minus alpha. And as I've already told you, the angle on right, the angle on a straight line is 100 degrees. So the angle, the sum of the angles on this straight line AB, or the sum of the angles, is always 180 degrees. So alpha plus y plus x, that equals to 90 minus alpha, is equals to 180, as you can see here. Alpha plus y plus x, that equals to 90 minus alpha, is equals to 180 degrees, because in a straight line the sum of the angles is always 180 degrees. So alpha minus alpha is 0, and if we subtract 90 degrees from both sides of the equation, then we get that y equals to 90 degrees. Okay? So y is a right angle. Now we will calculate the area of the trapeze in two ways, and then we will compare the two ways to each another, because it is the same area, of course, because it is the same trapeze. The first way that we calculate the area of the trapeze is actually the area of the trapeze equals to the sum of the parallel sides. The A is parallel to B, so it is A plus B, multiply by the height of the trapeze. The height is A plus B, so it is A plus B times A plus B, divide by 2. So this is the first way to calculate the area of this trapeze. It is A plus B times A plus B divided by 2, or it is A plus B squared divided by 2. And the second way to calculate the area of this trapeze is actually, we can say that the area of this trapeze is the sum of the three triangles that the trapeze composed of. It is this triangle, the area of this triangle, plus the area of this triangle, plus the area of this triangle. The area of the trapeze is equal to the sum of the areas of the trapeze, of the three trapeze. This of the three triangles. This triangle plus the middle triangle plus the third triangle. And actually the area of the right triangle equals to the base, that is A, times the height, that is B, divided by 2. So it is A times B divided by 2, and the area of this triangle is also the base, that is the B times the height, that is A, divided by 2. So it is A times B divided by 2 plus A times B divided by 2 plus the area of this triangle, that is also the base C times the height, that is C divided by 2, or C times C divided by 2. So in total, the second way to calculate the area of the trapeze is the area of the three triangles that the trapeze composed of. So it is actually A times B divided by 2 plus A times B divided by 2 plus C times C divided by 2, or 2 times AB divided by 2. It is actually A times B, because the 2 divided by 2 is 1, plus C squared divided by 2. So in total we get that the area of the trapeze is A times B plus C squared divided by 2. So by comparing the two expressions, we got, by comparing the two expressions, we got actually we get the Pythagorean theorem. So we calculate in the first way the area of this trapeze, and we will compare it to the calculation in the second way, and by this we will get the Pythagorean theorem. Or we can say that actually the area of the trapeze, when we calculated it by the first way, was A plus B squared divided by 2. It equals to the area of the trapeze when we calculate it in the second way, that is the sum of the three triangles that the trapezium is composed of, we get the c squared divided by 2 plus AB. It is actually AB divided by 2 plus AB divided by 2 is equals to AB. So actually, of course, the area of the trapeze, when we calculate it in the first way, equals to the area of the same trapeze that when we calculate it in the second way. For this reason, this expression equals to this expression. Then we can multiply this equation by 2. So a plus b squared divided by 2 times 2 is a plus b squared, and a plus b squared is equals to a plus b times a plus b, and c squared divided by 2 times 2 is c squared, and ab times 2 is equals to 2ab. Okay, then we can open the brackets of this expression. A times a is equals to a squared, and b times b is equals to b squared. Then we have b times a and a times b. So b times a plus a times b is actually 2ab equals to c squared plus 2ab. Then we can deduct from both of the sides of the equation the expression 2ab, and at last we get that a squared plus b squared equals to c squared. And this is exactly the Pythagorean theorem that actually says that the square of the hypotenuse is equal to the sum of the squares of the perpendiculars. Okay? A square plus b square is the sum of the squares of the perpendiculars equals to the square of the hypotenuse, that is c squared. Okay, so this is the proof of the Pythagorean theorem. You can find in the internet a lot of other proofs, but it is actually this proof is the proof of the President of the United States of America, the President Garfield, that was the 20th President of the USA in 1876. So, okay, thank you very much.